day. May I introduce myself? I am Angelica Kaltakad, BSCS 4A. My presentation is all about Lamport Mutual Exclusion Algorithm. In this topic, I will discuss what is Lamport algorithm, what are the message complexity, the drawbacks of this algorithm, the performance, and also some example of this algorithm and my own conclusion about this topic. Lamport Mutual Exclusion Algorithm. What is Lamport algorithm? Is a permission-based algorithm proposed by Lamport as an illustration of his synchronization scheme for distributed system. Requests for CS are executed in the increasing order of time step, and time is determined by logical clock. Every site SI keeps a queue, request queue, which contain mutual exclusion requests ordered by their timestamp. This algorithm requires communication channel to deliver message, the FIFO order. And also, Lamport algorithm is a critical section requests are processed in order of timestamp in Lamport algorithm. Therefore, a request with a lower timestamp will be given permission to run critical section first, followed by request with a larger timestamp. Algorithm. There are three sections here, which is the to enter critical section, to execute the critical section, to releasing the critical section. In enter critical section, when site SI wants to enter the critical section, it set request message request to all other site and place the request on request queue. It donates the timestamp of site S1. When a site SJ receives the request message request from site S1, it returns a timestamp replay message to site S1 and place the request of site S1 of request queue. In execute to the critical section, a site S1 can enter the critical section of it has received the message with the timestamp larger than from all other site and its own request is at top of request queue. In releasing the critical section, site S1 upon the existing, the CS remove its request from the top of its request queue and broadcast a timestamp release message to all other sites. When a site SJ receive a release message from site SI, it removes SI request from the each request queue. When a site remove a request from each request queue, its own request may come at the top of queue, enabling it to other to enter the CS. Example. In this figure, there are three sites, which is the S1, S2, and the S3. S1 and S2 boost requests in critical state, but S2 is the first one read the timestamp, so should be the first one to enter into the S2 in the critical state. S2, we all can also see them as associate with other sided from S1 to S2 and so forth. The message is to the end, which is this one on the critical statement mean it asks for on the resources. S2 receive 1 and 2 because there are two places where the message to be passed. It has request execution and critical statement again on the pre-algorithm step as follows. First request the critical statement and execute and release from critical state so that they can use by the other process. Step 2, it has to be being asked by the first time the time stats being forced causing to enter into critical state. Step 3, when S to enter into the critical state in releasing all the resources. In this algorithm, there are three types of message, the request, replay, and release. In the request message is to all other sites to get their permission to enter critical section. And the replay message is to requesting site to give its permission to enter the critical section. And the release message is to all other site upon exiting the critical section. Every site keeps a queue to store critical section requests ordered by their time stats. Three are used and communication channel are assumed to follow FIFO. What is FIFO order? FIFO order is a model. Each channel acts as a first in, first out message queue, and thus message ordering is preserved by channel. Lamport algorithm required invocation of message per critical section execution. There are the request message, reply message, and the release message. In total is equals to 3 and minus 1. Drawback of algorithm, there are two, which is the unreliable approach and the highest message complexity. In unreliable approach, failure of any one of the process will halt the process to entire system. In high message complexity, algorithm requires in 3 and minus 1 message per critical section invocation. The performance of this system is synchronization delay is equal to maximum message transmission time. It requires 3n minus 1 message per CS execution. Algorithm can be optimized to 2n minus 1 message by omitting the replay message in some situation. My conclusion in this sub my conclusion in this topic is, though it does not explain the modern scenario of distributed system, but it gives the basic of developing the present way of handling distributed resources. Thank you.